Hello friends, in the previous session of Introduction to Python, we talked about some basic commands. In this session, we are going to explore some further Python basic commands. Now, we are going to take input from the keyboard again and print that input. By default, input function takes input from the keyboard, the standard input. So we have to enter this command. Suppose we enter here this command. First we start Python interpreter. I have started already, and now I give this command. Numstr is equal to enter input and number. This input function is for taking keyboard input. We call this function by writing its name input and pass a parameter, enter a number, for us to understand what to do. Suppose I press the enter key. Now you see it asks for a number to enter. So suppose I am entering 24. Now we see it has taken numstr as 24, but it is not in numeric format because by default the keyboard input returns a string value to us. So numstr is a string actually. We can check it by the command type. This type and numstr. We call the function type to check type of the variable numstr which we have taken from the keyboard. Now I press enter. You see it is str type, means not string type. Although we have entered 24, a number, but it has been treated as a string in Python. Now what to do to convert this string 24 to numeric format? We have to convert this like this. Suppose I assign a variable num is equal to int, then numstr. What I do here, I am calling the int function to convert this numstr to numeric format, integer format. So this int function converts this numstr to an integer form and assign the value to num variable. Now we can check the type of the num variable. You see here, this is an integer plus int type. Suppose I give, I want to print this. What should I do? Simple the command to print, as I have already told you, like this here, print. I am calling the print function and passing two parameters. First, a string enclosed within double quotes with characters you entered. Then after comma, I pass a second variable num, which has been converted to integer type, and I want to print this. So I press the enter. It is printing you entered after one space and this 24. You see, this is you entered is a string and num is an integer here. So it is by default it converts first num to string type and concatenates or adds this to you entered. So here two strings are added. first num is converted to the string and it is added to uintered. Then this whole becomes string and printed. So it prints uintered 24 here. Now we have to understand how Python works or Python environment. Python files are saved in a format with extension name .py. Giving .py name, it understands this is a Python script file. But since computer doesn't understand our English language, so first it converts to a format which can be understood by computer. Internally it converts it in a bytecode format. .pyc file. This .pyc file may be run on the machine, although it is not a machine code file. It is still a intermediate file. So here this Python, when I run a Python program that with a file, that file with .py extension, the instructions of that file are converted and a new file is internally generated. That is a bytecode file with extension .pyc, and it is run at the same time after converting, although we don't see in the interpreter, but internally it happens. And in the interpreter, when we run line by line, then that English like line is converted to bytecode and immediately it is run in the machine. So although we don't see this generation of .pyc file, you see here suppose my file's name is m.py, Python file. This is called source file. This is Python program file written by us. When I run this file, Python file, it internally converts to a bytecode file with extension m.pyc, and then it runs or sends this file to Python virtual machine, means the Python runtime environment which runs the bytecode file. This pyc compiled file is not a machine code. That is generated when compiling C or C files, C or C++ files. Because machine understands only instruction in 1 and 0. So it is not machine code, and by this, this is not so fast as C and C++ code, because C++ code generates directly machine code files, which machine understands. But this pyc Python compiled file will have to be again converted to machine code for running it. Like we run a C program, a C++, a Java program, we need to compile that source code first. In Python, we don't need to compile. Python environment automatically compiles that file for us. Some Python versions, main version is C Python. Some version Python for Java, JPython or Iron Python. There is just-in-time compiler also. But mainly C Python is used. Now, how to write a file? And first run it. Suppose I write this code. A little bit, this is actually, you understand that this this character, this hash character, instructs Python that after this hash character, everything in that line is not a code. It is just for our understanding. So it is called comment. Anything after this hash code is called a comment line. Python doesn't compiles that line or doesn't run it. This is purely for our understanding. So there are two comments. First is this hash codes. Single hash code is enough to make it a comment line. I have put it here four hash justified for the beautification. Suppose after hash I write this file1.py. This is I know that its file name is file1.py. Although it is not necessary, these two lines which are comments are absolutely not necessary for running the program. Similarly, this last line is for beautification only. It is not needed. Actually, and these are also not needed. Suppose I have written here import sys, then I have written here this hash load Python. This is for our understanding. Import sys, this is for loading Python library module named sys. This is for our understanding. So this everything after hash character is ignored on that line by the Python. This is for our understanding. So from here to here, I have written a file in text format and saved it as a file1.py, and we can run that. I'm opening this file. You see here file1.py. This is the actual file is here. You see these two lines are comments and the last line is also comment. Also after the every instruction, this I have put comments. These comments, these are not needed. So import sys means I am importing sys module. Sys for system module named sys from the Python library, and I am using this load Python library module named sys. And the second instruction is print, calling a print function and passing this sys.platform as a parameter. How I am importing first sys, and in this sys module there is a attribute or variable platform. Means I am instructing or passing here sys.platform means the name of operating system of our computer. It is it can be accessed by sys.platform attribute. I am just printing what is the name of our operating system by calling this print function and passing sys.platform. Again I am printing by calling this print function 2, then $5. Double star means single star is a symbol for multiplication. Double star is a power operator, means 2 to the power 5. I want to print 2 to the power 5, so I have to write here 2, then double star, then 5. And this whole value is enclosed within brackets to be printed. Whole value is passed as a parameter to the print function. Again, I am assigning this x is equal to test. Test is a string here, enclosed by single character. And that string is assigned to x, means x becomes test, then exclamation marks, this whole string. Now I want to print this x 4 times. So I call this print function and passing x into 4. Now here you see 4 is a number and x is a string. So number into number is understandable. Why? But a string into number, it internally interprets as I want to print the value of string 4 times. Like x is equal to test here, so I want to print test, 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 test. So actually this is a repetition operator. When an integer is after any string with star sign, means that string is to be repeated 4 times here, because I have written 4. So this is a repetition operator. If x had been a number, then it becomes multiplication operator. But with a string and a number, this star signs represents a multiplication operator. You have to keep that thing in mind. Now our file combines only this main 4 instructions. And if I want to run this file1.py, so I have to write here first I have to exit it, because I am directly writing name of the file or executing our file. So I have to go to the OS terminal. I am right now in Python terminal, because this is this 3 greater than. I have to exit. To exit Python interpreter, I have to write here. I have to call exit function and opening a bracket and closing bracket. Then I print enter here. Now I am out of my Python interpreter. Now I want to run my file1.py. For this I have to be in the same directory in which file1.py is stored. I write here Python file1.py. The Python is a command which runs the file, and now I am passing this file1.py means name of my file as a command line parameter. I am in the operating OS command, so I am writing here Python, then after some space vector I write the file name file1.py and press enter. So it runs each instruction which I have stored in my file. So what comes out? You see here output is Linux, means name of my operating system, and this 32 is 2 to the power 5, and this test, this is using a repetition operator, printing test string 4 times. So whatever instruction is stored in my file1.py is executed by Python. Being on the command prompt, I write Python, then space, then name of file, and press enter. So it prints, it executes each instruction in the file and prints the result. You again see here printing the sys.platform, then printing 2 to the power 5, then printing string 4 times. I want to save what is the output of the file, output of running this Python file in another file. So I write here Python, then file name, by giving this command python file1.py, it executes each instruction in the file. Then that output is stored in a new file named save.txt. I can give it any name. I have given here save.txt or any name. This is redirection operator, means you execute commands in this file file1.py, then whatever is the output, you redirect that output to the save.txt file. So I may give it this command, and now I want to see what is stored in my file save.txt. You see here the same output, the name of operating system, then 2 to the power 5, then test results. This is stored with a name save.txt. So output of Python can be saved to a file also. In some, although I have written here executed Python files by writing the command python and then file name, on recent versions of Windows, we can directly run Python files by writing the name of the file, right? Like here, file1.py, directly on the operating system command. By the .py extension, it understands that it is a Python file and automatically runs on some recent versions of Windows. On some Linux system, we can write some command or make executable files directly and run that files by, suppose I like to run this script file like in Windows, directly typing the name of the file and running it. For this, on Linux system, we have to write a file, and the first line of that file should be start with this #bang, hash character, then exclamation character, #bang. After that, we have to write like this: user bin env python, means contents of this file is to be run by Python. And after that, after the first line, we can write instructions. I have written here single instruction: print name of the person is Shyam. This 2 strings to be printed. Suppose this is my file, and on Linux we have to make it executable, like here chmod +x, then name of the file, script run that file. Then to run this file directly on the Linux command, I have to give this here // name of the file directly, script1.py, then it will run like Windows also. Now file1.py, as I have created just now, is an executable file. We can import that file in our Python interpreter. You see, I have written here import file1, means I am importing all the instructions of my file1.py, the 3 instructions. And whenever I write like this, suppose I restart this Python. Suppose I write import file1. You see, on the command prompt, on this Python environment, on the Python prompt, I call a instruction import, then name of the file, my file1.py without extension name. This is the method to import any module of the file. That module name is to be given without the extension name, without .py. So I am importing my file1. The instruction of my file1.py file by writing this instruction, import, then name of the my Python file, file1. When I press enter, it executed all the instructions in my file, and actually by importing we execute all the instructions of that file line by line. This is shown here. The output of these instructions is printed on the screen. But this happens only one time. Whenever I import this file1, it runs all the instructions and prints here. Again, if I import file1, nothing happens because not needed. Once all the instructions output have been loaded in the memory, then again calling this import is not needed to run all the instructions, because all the output are stored in the or loaded in the memory. There is a technique to reload all the instructions like this here. Import lib here, from import lib. Import lib is a library of Python. From import lib import reload, and calling this reload, then passing this file1 name of the file, then again it reloads. If I give this command import right here, although these things are not so common, but just for illustration I am giving here. You see what happened? From import lib, import reload. Import lib is a Python library for importing modules, and in that library there is a function reload. So I am loading this reload function and using here this calling function reload, then passing my file's name, main name of the file1.py without extension name, and then pressing enter, it again reloads the instruction in my file. I can import all the instruction or any attribute name. Like suppose I saved a file with name file2.py, and in that I am writing only a single statement here. Title is equal to I am happy, like this. You see here, this is file2.py with it is Python file, and there is single variable title. Its value is I am happy. This is a string. So file2 is the file name, and in that there is attribute or variable name title. To access this, we have to write file2.title. Right here you see. If I import file2, first I import, then all the instructions in that file2 are imported in my memory, and to access my title attribute I have to write file2.py. But means file2 is a module name or file name, and the dot operator and the attribute name title. So by doing this Python prints the value of this title attribute, that is I am happy, because I have saved this title is equal to I am happy string in my file file2.py. So I am here just importing file2, then this file2 dot title. You see, by writing this file2 dot title, it accesses the title attribute of file2 module or file2 module, and after pressing enter it prints its value. I am happy. So any attribute of my Python file can also be accessed first by importing that module or file, and then using the dot operator to access the attribute. Another thing is like here using the from command. Like here you see, I can directly access this title attribute or file2 module like this. Here. From file2 means from module file2 import this title. This is telling that import title attribute of the file2 module or file. Import title attribute from the file2 module. So value of title is loaded in memory. Now I can print here title. Pressing enter. I am happy is printed here. So there are two methods. First import my module, import file1. Like here import the file2. Then all the instructions of file2 have been loaded. Then I access this title attribute of this file2 by file2.title. In this command, I am directly accessing title attribute of the file2 module. Title value is loaded in the memory, and to print it, I write here the attribute name, then press enter. It will print its value. I am happy. So these are the some ways are to importing modules and accessing their attributes or calling their functions. Again, one thing is directly opening the file and executing that commands. Like here, you see this command. We will talk about this later on when dealing with files or some other thing. By the time you just keep in mind that I am calling here exec function. Then within this exec function, I am passing this instruction. This instruction is in two parts with the dot operator. First is calling this open function. I am passing file1.py, means name of my file file1. So this instruction open function, then passing name of the file file1.py within brackets. This causes to open my Python file named file1.py. This command opens and a file object is created, and after using dot operator, I call this read function. Read function of the file object. So this open file1.py opens the file1.py and creates a file object. Then I call read function of this file object that reads file1.py each instruction and loads in the memory here. That this each instructions line by line are passed here as a parameter to exec function. Exec function just runs the whole instructions. Then the output is Linux, the same output what we have seen here. This method is also not much common, but sometimes you can use it. You see, on the Python command prompt environment, we have given this exact function, then opening file and reading, then read function reads the file, then this contents of the file is passed here as a parameter to the exec function. Exec function executes each instruction and runs. So I am here directly executing contents of my file1.py in a single line in the Python environment. Another thing I have to tell you that dir is a command which lists all the attributes names in that file. You see, I am giving here dir command. Dir, then I am calling dir function, passing the name of my file name of my Python file without .py extension, means dir, then within brackets file1, and pressing hit here. See, this prints a list of all the attributes of that file. These are built-ins, are this a cache, these are the Python things. We may call it later. You see here, sys is attribute because sys has been imported my file, and x. In my file1.py, I had written a x variable and imported sys. So these two attributes are printed. Means dir function, after giving file's name, prints all the values, all attributes of that Python file. Command line arguments are what we give on the command while running a Python file. Suppose I have created a file like this. This is a starting with a hash character. This line is a comment. Last line also is a comment. This last line is a comment with hash character. Only the main contents of the file are like here. And I have created a file named cmd.args.py. cmd.args.py is a Python file. You see here sys. I am using first instruction as import sys, importing sys module of Python and printing this string. Now this is the first string is all command line arguments. This is printed as it is, all command line argument. Then after comma, I am giving a sys.argv, means argv attribute of the sys by calling sys.argv. Actually, sys.argv stores all the command line arguments which I have given. Command line arguments are the values which are given all on the command prompt while calling or executing a file. Like here you see I am giving Python, then file name cmd.py. I am executing this cmd.py Python file by giving Python, then file name cmd.py. Now this after this file name, I am passing three command line arguments. First is my, then next is 1, 2, then this is books, separated by space character. So after the Python this command, the file name cmd.args.py is stored as a first parameter. My is stored as second parameter. This string 1, 2 is stored as a third parameter, and this books is 4. Actually, it is started by 0. This cmd.args.py at 0 index, my at first index, 12 at second index, and books at third index. And all these parameters, file name and these three my parameters, are stored in a list like structure RB. RB0, RB1, RB2, we can access this. Actually यहाँ पर RB0 is the first parameter, means name of the file. Then RB, this one is the first parameter, and RB2 is the second parameter. So this RB contains all parameters. sys.rb0 is the file name, actually first parameter. Sys.rb1 and all, actually rb1 is the second parameter, and I am using here slicing column. Then this we will talk about it later. You just keep in mind that I am printing the rest of all the parameters after the this first parameter and all the here. So what is printed here? First, I have to exit this. I'm opening another terminal window and giving this command here. Python, then cmd.args.py, my file name, then the three parameters separated by space. When I run this, you see here all commands line argument. You see the Python file here. First it imports sys module, then it prints all commands line arguments, then sys.rb. Sys.rb contains all the arguments, so it is printed here. cmd.args.py, this is at 0 index, my at first index, 12 at second index, like this. Then the next is first command line argument, sys.rb0. rb0 means the first one, means the Python file name. What I write after the Python command, this Python, then the file name, which file I have to run. This file name is stored at the 0 index, rb0. So we call it like sys.rb0. So here it is printed first argument, cmd.args.py file name. Then the third line, other command line arguments, you see here my, 12 and books. All the parameters after the first, means the after the file name, means my 12 and books. These are stored in a list, and I have printed that using this sys.argv1 colon. Actually, it's a slicing operator. So likewise, we can print or know any parameter values which I give while running a file by using Python command. Python, then name of file, then after that command values separated by space. I can print all those command line while running the file. So this closes the second part of my tutorial. In the third part, we will talk about some other topics. Thanks.